Okay, good afternoon, everyone. My name is Elma Amupolo. I'm from Namibia University of Science and Technology. I'm a recent master graduate. I am actually representing my supervisor, Professor Vera Dikawa. Unfortunately, she cannot able to make it here, so yeah. Um, I'm experiencing some problems. Mm. Yes, sir. Oh, 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 the problem is the overs. Okay. Okay, so I'm a recent master graduate, so my topic was actually on assisting region tree regeneration for sustainable forest and woodland management in Namibia. Just to give you the overview of the project, uh, why are we really looking into tree regeneration? We would like actually to know, oh, like people they have different perceptions. Some they are saying the savanna woodland actually they regenerate naturally, so there is no need to assist tree regeneration. But then now, due to the climate change, we actually need to assist tree regeneration. Now in the woodland in southern Africa is actually facing a lot of challenges, the pressures from degradation to land use changes, as well as now poor regeneration due to the climate change. So the aim of this project is actually to explore different sustainable ways in order now to enhance tree regeneration for resilient forest and woodland management in Namibia. Uh, the project has contributed to the work package, for example, like to assist regeneration of radium trees. This was actually done in a necessary condition in a pot experimental where we actually have to inoculate the soil using the PGPR. Yes, Professor Barbara actually said that this one they are adapted to the harsh environmental condition that can actually survive in high temperature from 38 to 40 degrees Celsius. We actually also contributing to the deployment and the dissemination of inoculation technology more on sustainable forestry. Uh, so on the research publication and academic output, we actually submitted our manuscript to the international journal called the Forest Ecosystems, and we have contributed our data to the Sasscal Sustain knowledge platforms. Uh, and also this our experiment has contributed to the experiment which was gained during the Sasscal phase 1, which was actually now on the inoculation of the Pterocarpus angolensis on seeds, but however this, we did not inoculate the seeds, but we inoculated the seedlings. We have also managed to publish a poster at the conference of International Union Forest Research Organization. That was in 2024. And yes, as I said earlier, that I graduated with my master's, so this actually has also contributed to, it's actually contributed to the academic output. Just to give a bit introduction to our research or the uh, I will just give the high impact results of our study. Uh, we actually also looked on different we also looked on different factors that affect the seed germination. We look on seedling depth, we look on the seed age and the seasons, and we found out that the season actually it's affecting the seed germination more than other factors. On the inoculation, we actually inoculate the seedlings in order to see if the inoculation can able to help the seeds to grow and also to investigate the survival of the seedlings. And according to what we got from our results, we found out that the inoculation was actually species specific to soil dependent. As you can see in Mopane, like the soil that was inoculated in sandy soil had a higher height than the seedlings that were not inoculated. Yes, and also for Terracapus, you can see in Romy soil, and in Kubushia Corosperma, you can see there was a bit growth in Romy soil. And for the survival, it actually improved the seedling survival for the Bacchia africana. On the human capacity development, we actually managed to train one at each study site. So, of course, I have two study sites, the at Ongava Research Center and the Mashara Irrigation Training Center. So we trained this research necessary assistant to take good care of the seedlings when I'm not around. And we actually also have engage with the researchers at Ongava because it's their research center. So we managed to showcase of what we are actually doing, and we actually have an opportunity to engage with local communities at Mashare. During now our work, we actually have I have gained skills on experimental design, data analysis, as well as scientific writing, because I have attended a lot of courses on experimental designs. And I have also attended the microbiology course, which was hosted by Sasscal. On the product and services, so our project is aiming now on to develop the necessary protocol that will help that will help with the guidelines on how really we can look into seed germination, seedling establishment, and also on transplanting the seedlings. And we have a trial, an ongoing trial at Ongava, the seedlings that were grown in a nursery. We actually transplanted them outside the nursery condition, and we are actually monitoring their growth and their survival. Same thing will happen at end of this month. We are going to transplant the seedlings that were grown at Mashare, so we are going to transplant them at Sia where other afforestation programs are taking place. On partnership and the regional collaboration, we had monthly sustained meetings, and we have also a strong relationship with Birmingham University, as they provided all the inoculation used in this study. And we have also have a stronger relationship with the Kahanja Seed Center, because they provided almost every seed experimental seeds. And we also have a strong relationship with these two study areas, the Ongava Research Center and MITC, because they provided the infrastructure, the logistics, as well as the technical support at no cost. Just to conclude, we found out on our study that the critical stage of growing these seedlings is actually lying between the post-germination and seedling establishment, and the treatment were actually the effect of the seedling were specific species, And as I mentioned earlier, that the season actually has affected the seed germination of many species. The inoculation, it was as well specific to soil dependent, and we are now working on the nursery and the transplanting protocols, and we are going now to monitor these seedlings that we grew in the nursery, outside the nursery. As you can see in the picture, the Terminalia prunoideus, it's having a tag in order now just to make it easier uh, to monitor them in the long run. The recommendation, we really want a study that will look into the linkage between the soil microbes and the nutrition uptake. As in our study, we really found out that the inoculation really depend on the soil. So we would like to see how this is affecting the seedling physiology. And this comes to the end of my presentation. So yes, thank you very much.
Thank you. Can I invite Dr. Tsele?
Good afternoon, everyone. I'm given 5 minutes, so it means I have to make sure I abide by the time as given. So first of all, my name is Phil Monsele from the University of Pretoria. And I would also like to acknowledge Professor Abel Ramuelo, who's my colleague. He couldn't be here. So both myself and him, we supervised this research that was undertaken by our student, Theo Tsuaneng, over there, waving a hand. So credit goes to you. Yeah, so yeah, so let me just shoot straight into the presentation. So the number of students that were supported here is only Theo, and her thesis is due for submission. Sorry, these slides, they don't look updated. I sent the updated ones earlier. The slides are outdated, these ones. Yeah, no, I'm not happy with the slides. I gave them the updated one. I was hoping to see the updated version of the slides. I gave it to the gentleman over there, next to the camera. I gave them a folder with 2 presentations, one in PDF, one in PowerPoint, under the Sustain Sasscal folder. Yeah, okay.
So apologies, attendees. Let's make some few changes. Let me invite then Prof. Roda instead, while we are sorting out the right slides. Thank you.
Good afternoon. Are you set there?
Lord, Prof. Roda's presentation, please.
Okay, thank you very much. This presentation is on behalf of Prof. Ngombe, myself, Dr. Osiku, and also two of our students. They are represented here. They can put their hands up. Thank you very much. Okay, so this is a sustained UNAM soil, University of Namibia, yeah. Yeah, the presentation follows that outline: introduction, main objectives, results, and conclusion. I realize that the introduction has been done already previously by Prof. Barbara and Professor Flora. So it is but the typical situation is that Namibia is a dry country. The soil is also less fertile, and therefore there is a challenge of low crop productivity, especially in the face of climate change. The rain comes at, maybe you may get too much, many times it's less rain continuously even for 3 years. And then, like for example, this year the rain was a lot. Last year and the previous year it was very little rain. So because of those situations, there has to be a solution that is climate smart, and this project of Sustain is intervening through three methods. One, use of drought-tolerant legumes, inoculation of those legumes with rhizobia, and finally, minimum tillage, conservation tillage, which is accompanied by minimum tillage and mulching. And those are supposed to really cushion the soil, plant, water system. Yeah, the objectives, let me not repeat because they've been stated already. If I can just say in my memory is that one objective is to follow the conservation tillage and see how they affect the crop performance. Again, another one is conservation tillage, how they affect the soil water condition. Conservation tillage and inoculation on how they affect the performance of the crop. And now all those affect the soil fertility. So our project is in sub-project A, C, D, and the last one is a combination of all where we deal with dissemination of information. So the treatments are, the green ones are the conservation tillage side, and the yellow one, or orange, is the conventional tillage. So I'll be showing you some pictures. That's the overall picture of the project, where the cowpea is the test crop. We have two varieties, and then we have Mahango pearl millet, where we are able to test the difference between the two. You will be able to see the N15 and see how, the Mahango in the middle or the pearl millet is intentional, supposed to help us monitor the biological nitrogen fixation. So other pictures is now in the tillage systems. I told you we have two systems, either using a tractor full time or using a reaper that is just able to open a furrow. You can plant within the furrow, and then so you don't disturb the soil as much. So we started by welding that particular implement to be able to open the soil and not to disturb a lot. So that is in Ogongo campus, which is in northern Namibia, close to southern Angola. So that is our bachelor student. And the same student, now the machine that you are welding is, it's 3 minutes, is what you can see it. Well, I'm not going to say much. And then the other alternative is using full-time tractor. I had a video there, but now it's not possible to show you the video on how we were welding and plowing. And then we have two varieties of cowpea. There are two colors. One is lighter and one is having and then the inoculant was faithfully delivered in person by Prof. Barbara. I don't know how you did it all the time from Germany when we wanted to plant. And we decided to do 2 seasons. Namibia has potentially 3 distinct seasons in the year. From December to April, you will have rain. From May to August, it's winter. You can do winter crops. And then from September, it's a silent time. September, October, before November. So we said, this period of September, we can plant a crop under irrigation and see how the cowpea behaves this time and how it behaves when the rain comes. Because there are farmers who want to plant something now, even as a cover crop, to plow into the soil to improve soil fertility before planting the main crop. So we had that set up. And then, of course, we did measurements of water and soil. We did the student is there standing. He's also standing in the experiment and really standing in physically. Okay, so that is the biomass, for example. That's the testing of the crop, yield, and the results in 1 minute, I hope. Interesting enough, there were 2 distinct performances. During the dry season, when you irrigate, one variety does well. During the rainy season, when you don't irrigate, you wait for the rain, the other variety does well. It's the opposite, almost in everything. And you can see almost all parameters, that's how the variety is behaving. The blue one is Nakare, the orange one is Silwana. And then effect of tillage. During the dry season, with irrigation, conservation tillage is doing very, very well. And then this year, when the rain was really a lot, conservation tillage did the opposite. So because the rain was too much, and then I think that there was flooding because there is no plowing that goes on deeply into the soil. Same for effect of mulch, sorry. During the dry season with irrigation, mulch is doing very well. During the heavy rain season, mulch is doing poorly, and also through the yield parameters. Inoculation. During the dry irrigated season, inoculation didn't do well. Instead, the nitrogen application. During the rainy season, inoculation did very well. So everything was the opposite. So, in brief, under dry season irrigation, conservation, tillage, mulching, and fertilization gave the highest results, and the opposite is the case when it rains. Yeah, so products, we hope to, with the help of the University of Bremen, have a rhizobium package that is able to reach the farmers. We would also wish to design and weld a minimum tillage tool that can be used by smallholder farmers. We have 1 PhD student, 1 master, 1 bachelor, and 1 diploma, all at different levels, between 50% to 95%. And we are preparing now 4 publications. The 5, that is cowpea growth as affected by, growth and yield as affected by conservation agriculture and conventional, soil physical-chemical properties with sample soils, and they are in readiness for testing. The effect of rhizobium on cowpea performance with and without during the different seasons, molecular characterization and microbial population of rhizosphere organisms, and soil water dynamics under the different systems of production. At least 2 theses to come out of this, and 2 policy documents. I think I should just conclude by saying we need to screen different cowpea varieties for different seasons. And then again, we need to see if the rain is anticipated to be heavy. Conservation agriculture is really well promoted by the Ministry of Agriculture. The Executive Director of Agriculture Namibia is here. And apparently now when the rain is really a lot, those days, the rare times when it's a lot, we need to package what we call conservation agriculture for different extremes of rain and dry season. At the same time, we realize that rhizobia performance is mediated by the season. If it is extremely maybe hot and dry, even if you irrigate, the rhizobia may not behave as well as you had thought. So those dynamics need to be looked at. Thank you very much for your attention.
Thank you, Doctor. Can I invite Dr. Tsele? I believe his presentation is ready now. Is it ready? Not yet. Okay, can I invite Prof. Chezuba? It's Albertina. Okay, sorry, Prof. Dr. Albertina, please help us to save time.
Okay. Where do I press? Okay, good afternoon. My name is Albertina. I'm working at UNAM. Ogongo campus is in the northern part of the country. Yeah, and I'm going to present our work assisting legume tree species regeneration in Miombo woodlands. Introduction has been done by colleagues. Maybe on this slide, what is important is the team members. We are working on work package 6 and 7, and work package 6 is looking at assisting legume tree regeneration, and we had 3 students. Each student is looking at 1 species. So we had Claudia Ipumbu, Arthur Mwilima, and Jonas Hambeleleni. And from the staff side, it's me and my colleague Elizabeth Deunyema. And we also have on the board Dr. Jesiah Nakanyala on work package 7. So the work that I'm going to present is mainly on work package 6 because work package 7 is ongoing. So the background has been kind of given, the challenges of the Miombo woodlands in terms of deforestation, overgrazing, forest fires, and that is exacerbated by climate change. And that leads to poor soils, and as a result, this sustained fall is now looking at how we can improve the soil by inoculating with different types of inoculants that we receive from the partners in Germany, University of Bremen. So the map on the other side is showing the Miombo woodland coverage and the stretch that comes to Namibia. So those are the 3 species that we were focusing on, Pterocarpus angolensis, Baikia plurijuga, and Gibotia chloesperma, each student looking at 1 species. One of the students is a master's student, while the other 2 are honors. So I won't talk about that map again. Those are seeds that we have used, and we have treated them differently. It was explained by Prof. Mojeremane. The pointer is also failing me. It's not moving. Okay. Yeah, so I'm not going to talk about much on the methodology. It was already spoken about, and the species and the bacteria. These were isolated from indigenous tree species in Namibia by the team in Germany that was working on this on other projects. And then they pass on the inoculants to us to apply on these seeds in the nursery environment. Yeah, we measured germination, we measured growth performance, and biomass. Growth performance in terms of height and biomass. Yeah, the pointer is not working anymore. Our results, nicking only enhanced growth performance, germination of Baikia prurijuga, but not on the other two species. Another important result that we got there is germination on P. angolensis was very low. It could have been due to waterlogging. There was a lot of rain this year, and in the nursery it was too much wet. So the germination for the other two species was slightly better. The results on growth performance were very mixed. There is no particular trend where we can say inocula have improved in terms of growth, because if you look, the better performing are the non-inoculated treatment. Yeah, so that trend was the same for all the species. However, something important I think that we could talk about is the the Enterobacter seem to have performed well in the two species, Guibotia, Cloispoma, and Baikia prurijuga. In conclusion, Enterobacter strain is promising, and perhaps it can be looked at again on another trial. We have looked at these strains in isolation, and perhaps if we try another trial where we combine different strains, maybe it can show a better results because they can complement each other in terms of growth promotion and also in other functions. So we need long-term monitoring studies to look at this. We are dealing with trees, unlike colleagues who are dealing with crops. So for trees, you need a longer time. Yeah, so partnership developed for the Sasscal Sustain 4. We had the money to plant the seedlings in the nursery, and we have ended there. So now we had seedlings that needed to be planted in the field, and we got partners from the University of Turku in Finland. We are working with them on other projects, and then we got some funding to take these seedlings in the field. In the field, we collaborated with local community and with the government, the Directorate of Forestry. We started socio-economic to understand the community first. For that work, we have published something in, and then we trained the community on how to plant the trees, and we gave them certificates, and then we went on to plant the trees. There are 3 different communities in Ohangwena region, and we have trained about, I think 30 community members in each community. Yeah, we found that these were timber tree species. The community's interest is more on tangible outcome quickly. So it worked better by combining timber tree species with fruit trees and also vegetables. They are growing some spinach around the trees. We involve the traditional leaders in terms of identifying the land where we can plant. Also now the government, we planted during the Arbor Day, Arbor Week period. And with this, we realize a lot of things need to be considered: land tenure issues and also water. There are policies for water which do not necessarily allow for commercial activities to take place, but rather for domestic purpose. So a full study considering the different dynamics with the different uses of the resources is needed. There is one publication out of this work, and our students have presented in different conferences that we host at UNAM. Yeah, and what else do I have? Yeah, so the way forward, we are still working on work package 7 to, we have data on social survey in terms of woodland dynamics from the perspective of the people. And we are yet to conduct the time series Landsat imagery analysis to understand how vegetation structure and vegetation cover is changing over time. Therefore, we expect more publication, 2 more on the above bullet points, and also a policy brief. I think that was my last slide. Thank you very much.
Thank you, Doctor. Can I invite Prof? And then we'll finish with Dr. Tsele. Thank you. We are almost there.
No, 5 is not enough. There's just 3 projects.
Oh, 7? You press this button.
Okay. Good evening now. So are we still in afternoon? Good evening. My name is Professor David Chizuba from Namibia University of Science and Technology. I'm also part of this SUSTAIN project. I'm agricultural economics by profession. When the proposal was written, I was drafted in for just an analyst for the entire project. That's why you see I'm coming last, because my assignment here is work package 11, which is a integrated agricultural economics assessment of cowpea bio nitrogen fixing technology under alternative climate scenarios. So I'm going to present, you will see they have presented the results on what they have done. I'm going to present the result of UNAM, the result of Botswana, and the result of NAST. I combine the result and do comparative analysis, and I do profitability, I do economic analysis, strategic analysis, and so on. So I wouldn't waste much time here. Barbara has motivated why the study was actually instituted here, but now the problem is why cowpea. Cowpea, she has also mentioned the importance of cowpea. And what I want to mention here is about the importance of the yield. And the cowpea can get up to 0.5 to 1.5 tons per hectare, up to 3 tons per kg per hectare. So, and nitrogen fixation is up to 60 to 240 kg per hectare. And so why I'm giving you this is when I go to the data, you will see the type of data we have now. So it's drought tolerant, it's a small scale agriculture that mainly produces in Namibia, and it has some nutritional value and so on. It's also objective, as I mentioned, integrated agricultural economics assessment. We want to integrate all the projects. And now do agricultural assessment. I will do economy-wide assessment, do profitability, what is the benefit nationally or across or specially, and so on. So the sub-objective now is, let's look at the historical yield and inoculation scenarios, which they have already said here, they have found this one better than this. Now you will see what my result says. It says, we look at, we determine the, historical yield under climate change. Climate change is a topic here. We look at climate effect. We look at efficiency of experimental design. Nakare, Silwana, TA, which one was better, which one is more dominant, which one is more efficient. We look at cost-benefit analysis, future yield changes. What is the future yield changes? The effect on the three projects, multi-market equilibrium, and the economy-wide impact assessment. This one, as opposed to use CGE model. To run this model, but the problem, there's a limitation here because of data, which I will still do based on Namibian side, because I will get access to Namibian data. So now, what did I do? I analyzed trends in data. You will see the trends now. I simulated yield and growth parameters using a DIASAT. You know DIASAT, somebody was presenting DIASAT here. Decision support a system for agro-technology transfer. DIASAT is a process modeling. You can use DIASAT, you can use EPIC, you can use AppSyn. There are a lot of them, but I use DIASAT. Now I simulated the effect of temperature rise on yield. I simulated production and economic returns, and to see which of this experimental unit is efficient, which of this experimental unit is profitable or is dominant. Okay, so now I use economic strategic analysis. I'll show you now the model I used. I use stochastic dominance. I use cumulative distribution functions, and I simulated trends in climate and impacts, and you see all the result now. So the result now, first of all, they sent me their data. I didn't conduct the experiment. My own is to analyze. UNAM sent me their data very late, even 2 weeks ago. Botswana sent me their data long time ago, of course. I got NAS data from close by, also a long time ago. So I was waiting for UNAM. I didn't see Angola. I didn't see any other person. So I analyzed the ones I saw. Now, if you look at the data is poor. Data is poor, I could say that. Look at the data. Now, analyze the yield. This is yield. Let me use my own pointer. This is the yield. This is the yield per each of the projects. That one there is not 000, it's 0.02. 0.02. It's UNAM data. This is the yield per ton per hectare. So this is the yield per kg. Actually, UNAM's data was in grams. I'm the one that converted it to tons per hectare. So you see the result is very poor. Like I mentioned earlier, cowpea is between 0.5 to 1.5 kg, or at least, up to 3 kg. So this is the result. And now the parameters they measured, they didn't measure it uniformly. Some people measure some of the data. We saw pod length, leaf number. Those things are not important. What is important is biomass, grain yield, and one of the most important parameters which I didn't see is a leaf area index. None of them measured the leaf area index, but harvest index they didn't measure. I also calculated the harvest index. So you see the parameters they have measured here, and you see their result. You see UNAM, I've gone too far now. Okay, you see this thing is not working. Too much light here. Yes. Oh, too much light. Okay. You see the parameters that are uniform. I saw the uniform parameters. Then you see NAST have 2 seasons, 2023 and 2024. UNAM has 1 season, and the Botswana, which is the name is this second Domboro or so. So these are the results. If you look at the results, you see pod number and so on, but the important thing is the yield. So let's move on because of time. So the first analysis I did here was to look at, okay, let me look at ANOVA and see what is going on here. And the ANOVA is not the ordinary ANOVA, it's the ANOVA, is the binomial ANOVA, just to see the effect of each of the treatment levels on the outcome variable, which is the yield. So I see the ANOVA here. Okay, let me, this moves fast. Slowly. Okay, so the ANOVA, let's look at yield, of course. You can see Nakara is doing well. In some units, you see Nakara from, that mash is Mashare. That Mashare 24, Mashare 23, this is Ogongo 25. This is second Domboro 24. Look at the Selwani, the TA and CA result. You see how the result looks. Now, this is the overall result. Look at the model effect. You can see the model is highly significant. And look at the R squared. R squared shows fine. The model is okay. The ANOVA model is okay. And so but now the individual effects these are the rhizobium treatment. Rhizobium treatment, Botswana had 5 treatments. NAST has 1 rhizobium treatment, and UNAM has 1 rhizobium treatment and control. Botswana had 5. So combined together, Botswana had experimental unit 184. UNAM has 24. Namibia, NAST has 12. But UNAM result, I cut it to 20 because there is an inconsistent mulch experiment which the software was complaining about. Then I cut it up to 20. So then we should look at the ANOVA. Is not so much important. Let's go ahead and go to the baseline prediction. I use the baseline prediction in DIASAT. We try to predict yield with the DIASAT according to all the projects. And I use normalized root mean square error to calculate the bias. We'll calculate the bias in predicting the yield based on each project. You can see the bias, how the bias looks. The bias means if there was no difference, then it will be equal. The bias will be 0. So when there is a bias, so you see that the yield was not equal and it was biased up. So look at the bias there. There was a very high bias according to the baseline model. Okay. I did it for NAST and for UNAM. Okay, I went ahead to measure production and economic returns. Now we are talking about experiment. We're talking about this and that. We economists will look at what is importance, what is the yield, what do I benefit from this experiment, which experimental unit is dominant, which experimental unit is efficient, how much per hectare money can I make out of this experiment? This is what I have done here. So what did I use? I use cost-benefit analysis. We use cost-benefit frontier. I use dominant frontier, stochastic dominance. I use stochastic efficiency. Then cost-benefit is about how much benefit do I get from what I have done. Is it to run an experiment and put resources, and that's the end. And you say, this one is better than this one. How? So the profit and loss will tell us. So now we should go to what do I do? In stochastic efficiency model, those of you who do economics, you see what stochastic efficiency says. Stochastic efficiency will look at which efficiency model, which one dominates which one. Stochastic efficiency is used mainly to measure inequality. You hear about a Gini coefficient used to measure inequality. So we use it to measure which of the 2 outcomes is better than the other one. So I use stochastic efficiency. It says we use mean Gini dominance. Stochastic efficiency is about calculating the mean and calculating, we call it Lorenz curve. You see what we call Lorenz curve. But in this case, I didn't the Lorenz curve, I have it. I didn't show the Lorenz curve. I showed the data, the data. So I use stochastic dominance. I'll show you the result now. There's a rule in stochastic dominance. The rule says if the mean of A is greater than or equal to the mean of B, and the Gini of A is less than the Gini of B, then A dominates B. At least with one strict inequality. This is the rule, in economic rule. Okay, we shall see now what the result tells us. So with this stochastic rule, we shall see what the result says. Another one, I use a stochastic efficiency frontier to look at what if we have said this one dominates with this one. Which of them is more efficient is what will tell us which one is better. I use it in the result here. The stochastic efficiency frontier says we are looking at utility frontier here. Utility, everybody knows what utility is. Our interest is to maximize our utility. Producer maximizes profit. Profit is his own utility. So we are a producer here. We are maximizing the utility. Stochastic efficiency frontier says that we calculate what we call a relative risk aversion. It's about decision making. It's about risk. So a producer, experimenter, you have put an experimental unit, okay? You have put an experimental unit. Which one is more efficient? So you look at the result. Now, look at the risk level. Look at the risk level. Are you risk neutral? Are you risk averse? Are you risk seeking? That depends on whether you make a better decision. Now let's look at the result. He has already shown me the time. So look at cost benefit. Cost benefit analysis, I got data from Namibia Agronomic Board about prices and the cost of fertilizer and the cost of, I got a cost of inoculant from Pesi and some other people and so on. I run cost benefit on it. You see that bionuclear fertilizer inoculation has a better cost benefit ratio than the other one. Then I calculated also ROI, return on investment. You can see they are also better in return of investment. I go straight to we call it mean Guinea dominance. Mean Guinea dominance tells you which of this treatment dominates. For Mashare, experiment number 9. I told you they are number 12. Number 9, CA, Nakara, BNF is what the result tells me. Now, which other one again? Ogongo. Ogongo says experiment 13, 14, 15 are dominant. Now, I told you, when you use stochastic dominance to identify a dominant outcome, and now when they are non-dominates, what do? Then you use stochastic efficiency to now isolate the three. So now, very soon, we'll use stochastic efficiency to now select from these three which one is more efficient. So we move ahead and go to Ogongo. Ogongo says, experiment number 42, conservation agriculture match Mahutuhuto and the commercial strain and the PGPR is dominant. Is it dominant? He says others, he said, no, they are not dominant. And I ran it under 1, 2, 4 runs. I did 4 runs. 4 runs means the more the year goes by, the more efficient you become. First run, 2 years, 5 years, 10 years, 20 years. As the year go by, you become more efficient. You may not be efficient in day 2, you may be efficient in day 5. So the efficiency, run 5, 10, and 20 identified experiment number 84. So now, we move ahead, mean dominance, stochastic frontier. Now I run it at DICEAT for Ogongo. Did I start with Ogongo? Okay. Now, no, this is not Ogongo. This is Mashare. Oh, I put one forward. Okay. Now this thing says this is the mean, this is the variance. This is called EV. When you see in research they say EV, meaning mean variance. Compare your mean and the variance. If you choose something that has higher mean and lower variance, you are more efficient. If you choose, you are risk averse. If you choose something that is high mean, high variance, you are a risk-seeking person. So now for this experiment, which one should you choose? This is identified 11. 11 has a high mean and low variance. Variance is 0. The other one identified, say 9. 9 has 84 mean, and it has around 300 or something variance. So I can choose 9. I can choose 11 there. So 1, 2, 3, 4. Which one gives us a better choice? He chose 9 here. He chose 9 here. He chose 9 here. So 9 is dominant in stochastic efficiency. So this is Mashari. So let's go to Ogongo. Ogongo says I see 14 here. I see 15 there. I see 15 here. I see 14 here. Then if we go back to what he chose, we chose there. He chose 14. So with this I choose 14. This is a decision-making frontier. Now you go to what again? We go to the next one is. Did I put 2 together? The next one is Secundomboro. Secundomboro, which one says 79? 79 has a mean 18, variance of 300 and something. Is preferred. Is efficient. So the other one is Guinea dominant. Here, this one is efficient. So I choose here. Based on that, 79, 79, 79, 79. You see, all the 4 frontiers chose 79. So that means if you go back to that 79, you will see that they are all referring to, they are choosing 79. What is 79? Somewhere there. Okay, they are choosing 79. So what is, if you go to let me just with this I'm done. Don't worry, my time is not yet. This thing is also fighting. Okay, so I don't know. So now you see 13, 14, 15. So now that thing identified 14. So now we choose 14. So out of the 3 that are not nothing is dominating, we choose 14 because of the other side. So that is, so this is not where our decision ends. So this is now a story because this has to do with climate. I saw climate experts here. So when they were talking about CMIP and so on, output. So we run experiment in ICIMIP. ICIMIP is a data portal. You go to ICIMIP, download featured climate data, downscale it with some experiment. Then you use it to determine which future trend are you expecting in Ogongo, in Yunam, and in. So this is what it says. For temperature and for precipitation. So this is the future trend. Temperature is going to be high. Look at, based on different climate models, this is what we got. This based on the different climate models, this is the precipitation, how it will look. For from 2015 to 200 and 100, 2100. I did decadal mean. Decadal mean means each 10 years I calculate the mean. Each 10 years, I calculate the mean. Each 10 years, I calculate the mean. Then I use it to run this. So this is how it will be. I use the latitude and longitude of these projects to download the data from ICIMIP. It's not a small thing. You don't think you just go there, you download data. You do some bias. You have to correct the bias in the data. And do a lot of things. It requires experts. I'm not expert in that one, but I know the data was collected in the correct way. So this is what the data shows. So with this, you can see that, we're now concluding, you can see that, of course, they have confirmed it. Bioinoculation, nitrogen fixation, it enhances yield. You see? And you can see if you implement it, it's a good thing to implement. But it has some limitations, of course. I will say that. CA, we have seen CA, we have just seen CA. Now, CA has some limitations as well. You must run all the pillars of CA. It's about 5. You must run all of them, and it must run it over years before you can conclude, CA is working wonderful. No. Another one is grain yield across site is low. You saw it there. And the treatments that were identified there, they are here. There it says the treatment was identified. So this is what the experiment is all about. So there is another one which I would do if I have data to run the economic impact effect of this climate change and this yield. But now the question is, how can you run economy-wide research with this data, this yield that is too low? So I will have to do some entire agricultural sector value chain analysis of Namibia, and if I have data for Botswana, I'll run it. Then I'll feed it into their CGE model. Then I'll run the impact of temperature increasing by 1.5 and see the result. Thank you very much.
Thank you, Prof. Can I invite my last presenter, Dr. Tsele? Please save us some time. We are squeezed.
Greetings once again. I'm Philemon Tsele from University of Pretoria. And as I've mentioned earlier, that I would like to acknowledge my colleague, Professor Abel Ramuelo, whom both of us have supervised the MSc or Master's Research that was undertaken by Theo Tsuaning. So all the results that you're going to see in this presentation is the fruits of her effort. So yeah, shooting straight to the project. So the sub-project, we focused on monitoring historical and recent forest development in the Kavango region and surrounds. So the work packages that we focused on, they are work package 7 and 12 on monitoring recent forest development using remote sensing and field data. And the second one was dissemination of geospatial outputs to support sustainable forestry practices. So yeah, the study area is based in the Kavango region, which is very close to the, is on the northern Namibian side, close to the Angolan border. And we focused on 3 communal forests, as you can see the map on the right, namely Mkara, Magoro, and Mbeo. So these are the 3 communal forests, and also 1 state forest called the Hamoye forest. So yeah, there are a number of issues in the Kavango forests, ranging from increasing deforestation. For example, there's illegal fencing, land clearing. Some of the areas are being transformed into agricultural fields. And luckily, we witnessed that ourselves when we did some field work last year in June. And there's also increasing degradation happening, which stems from the increase in fuel wood demand and illegal logging. But these are also exacerbated by climatic stressors like droughts and also annual fires that we have found have been happening for the past 9 years. So all these collectively, they intensify biomass loss. So what we've also noticed that is an issue is the monitoring systems. So there is a lack, or let me rather say weak monitoring systems, because to monitor these effects in these forests, normally it's a manual exercise that is being done. You know, they drive cars inside there, they walk in order to check for these issues. So it's a manual exercise, and given the large scale, looking at how big the area is, that is not viable. So one of the contributing factors coming from this study is proposing the use of satellite remote sensing data and the integration of multi-sensor products coupled with machine learning to facilitate large-scale monitoring of these effects. So yeah, as I've mentioned earlier, we have 1 student who undertook this research under our supervision. And then her thesis is expected to be completed by end of October 2025. The academic output expected, of course, is the MSc thesis. And then luckily there is a book chapter currently in press. So this work was also presented at an international conference in Cote d'Ivoire last year. And point two and three, there is upcoming journal papers. So these already are completed as technical chapters in the thesis. What we're just waiting for is for the student to just publish them. So yeah, with regards to a summary of the methodology, so the field data was acquired. We acquired field data comprising the diameter of breast height, tree height, as well as species identification. And then the other point on satellite remote sensing. So we also acquired the GDI, which is a space-borne LiDAR data set. This was critical for developing models for estimation of tree height. And also looking at the active sensor and the passive sensor. So we used the Sentinel-1 synthetic aperture radar data set coupled with Sentinel-2, which is a multispectral data set. The integration of these two data sets gave us an advantage in terms of deriving variables such as texture-based variables, vegetation indices, which the combination of these were then used to develop models for estimation of above ground biomass and also tree height. So above ground biomass and tree height, these are well-known key vegetation biophysical variables which are important for monitoring forest changes as well as their ecosystem functioning. I also wanted to indicate in terms of the temporal scale that the period we looked at was from 2015 to 2024, but there was also a tri-annual exercise looking at the changes that were occurring after every 3 years within that period. So this is a snapshot of the results. So the data set that was produced following the methodology I explained before was the high resolution canopy height maps spanning a 9-year period for the Kavango forests. And on this table what you see, this is the best model retrieval performance for tree height estimation. And this was achieved by random forest, so compared to the gradient boosting machine learning method. So these best models highlighted in bold under different scenarios were then used to produce or to do spatial prediction of tree height, as you can see on the far right. So those maps we did as a prediction of tree height across those different years, 2015, 2018, 2021, 2024. And what is important is the model was able to predict a range, a tree height range between 3.87 to 12.25 meters across the region. And if you can see the color variation shown on the maps, it suggests that the spatial temporal variability of the tree height, it's also affected by other factors such as deforestation, degradation, and regrowth. You'll see that later on when we amalgamate this with the above ground biomass changes. So, and a similar exercise was also done to estimate the above ground biomass. But what I would like to draw attention to is this map here, which shows the change maps of the above ground biomass, triannually and as well as looking at the entire period from 2015 to 2014. So what is interesting is if you can check that map on the top right corner, there was the model picked up a notable degradation across all these different forests regions. And later on, we tried to identify what could have been the possible drivers for this notable degradation that we see. And we found that there was, prior to that event, there were significant drought coupled with fire, and very little rain, as you'll see in the next slide. And also what is important, where you see that yellow, that line, saying illegal fencing, land clearing. Fortunately, last year when we were doing field work, we were able to notice that there was some illegal fencing, using those small tree trunks. And one of the community leaders were with him in the forest. He was also not sure who are these people who are doing this illegal fencing. And within the area they've demarcated, there was I would say there was some land clearing that was happening. So meaning that either that land would have, they're preparing to convert it to an agricultural field or something, we are not sure. But what is interesting is that the model was able to pick it up. If you can look at that red patch there, which shows the deforestation, that was what the model was able to pick up. And then, yeah, on the bottom right, there's another area we've indicated restoration areas. So those are the areas particularly along the road or closer to the road, but largely with the, there's a lot of settlements there. But we suspect those areas that could have been largely due to agricultural activity because the people who are residing in those areas, they do a lot of plowing. So yeah, so this was an extra effort taken to look at the contributing factors or the drivers to the changes that were shown or that were predicted by the algorithms. So we can see that we looked at there was severe drought episodes from 2015 to 2017, followed by fire peaks as well, shown here in terms of using the ban area product from 2017, 2019, and 2013, followed by low monthly precipitation within those years. So these were some of the contributing factors. So yeah, I'm about to complete now. So the spatial maps produced, they allow for early detection of hotspots, enabling the interventions against illegal logging and other effects that affect the forest. And then the second point is that these findings, we anticipate that they will equip local managers with the evidence to prioritize restoration zones and safeguard resilient areas. So the key takeaway point from this study is that this study has successfully demonstrated the potential of using satellite remote sensing data to facilitate near real-time detection and monitoring of forest changes at a large scale. So of course, there's still some room for improvement. Looking at the results, we still need more field data in order to calibrate these models, in order to improve the future predictions of above ground biomass and height, of course in relation to the climatic variables and environmental variables in the Kavango forest. Okay, my last slide. So the partnerships and regional collaboration. So in terms of institutional engagements, we'd like to thank all those listed institutions, point 1, 2, and 3. And also because, I mean, through this engagement, this facilitates, access to the forest. I mean, without a proper, relationship with the community and community leaders, you won't get access to the communal forests. And also data sharing, I would like to thank our colleague from NAST, who was able to share with us the data, including the Ministry of Environment, Forestry and Tourism in Rundu, was able to share with us some of the field data, which was very instrumental in validating the models that you've seen the results of. Thank you very much.
Thank you, Doctor. Can we give them another round of applause, please? Okay, it was a marathon, but it's important for us to listen to the solutions which were presented to us on food. Food is very important. I think it's for that reason we are still sitting here today, because we ate breakfast and lunch. So I will then invite 2 comments or questions. Can I have the floating mic here? Floating mic?
Oh, thank you, moderator, and thank you, presenters. Very, very informative. I just have maybe one or two comments that I did observe. This is something to do with the equipment, the machinery for testing the samples that seem to be a problem. I think two speakers spoke to them that they have to outsource to look elsewhere. And then again, the neighboring countries' equipment seems not to be working, so they're unable to test. And even more worse, that this could likely affect the completion of studies by one of the students who is like due to submit to complete his studies this year. So what plans are in place, maybe Barbara, because your university was supporting initially, and also the question to the PIs is what was the initial plan when this project was conceptualized? Were we going to be testing on charity, or there was a plan, or you had a machine that since gave in, so now you have to look elsewhere? And then lastly, I want to believe there will be savings so that we don't repeat this thing again. So we should consider a situation whereby we keep the labs in the right institutions for future studies of this nature, because it's all about food here. So thank you.
Thank you. Can I take another one? Barbara, just hold on. Can I have one more? None. Thank you. Barbara, you can go ahead.
Yes. Okay. Thank you very much for this comment. It's very important indeed. So the first thing is the equipment is very, very expensive. It's like several 100,000 euros. And you need specialists to operate them and money to keep it operating. So it's no easy option to simply buy one, not from Sasscal money. The original plan, so what we do with our samples, we send them to laboratories, but it's in Germany or in England, but that's pretty expensive. And the idea was to do it as in the years before, to send them to South Africa.
Yeah, no, I just want to put it in context. Stable isotope mass spectrometers are extremely expensive. In the southern hemisphere, I remember many years ago when I was doing my PhD, there were only two. No, there were three. One in South Africa, one in Australia, and one in Brazil. They're extremely expensive. And also, I don't think it will be cost effective at this time for us for Botswana to acquire one. I mean, they're expensive, but normally it works. It's just that it was unfortunate that at the time when we needed to send our samples, the two main ones were down. One, they were renovating the lab, and the other one had a breakdown. But it's okay, we'll manage. We normally budget because we don't have it, we budget to send to South Africa. Thank you.
And the last solution would always be to send them samples to Germany, and then it's more expensive, but if the funds are there, it's doable.
Thank you. Can you give my panelists, my presenter, another round of applause? Thank you very much. Welcome to the end.
Yeah. Please, you can disconnect this mic. It means no presentation more for today. We will move the presentations for next day, but now, please, a round of applause for this man. Thank you very much. Yeah. Thank you very much. We have a very short announcement for students. Two announcements for students. Who has oral presentation for tomorrow should send to Dr. Musonda today. Email your presentation to Dr. Musonda. Who has poster presentation In the morning, yearly, they should meet Dr. Musont. Usually, Dr. Musont is sit down there in the corner. But maybe they will meet him in the hall. Now, we need to gather people in the center. The center will be the Secretary of State for the group Pisha. You please come here to take this. We will place people here in the center. We need to take a group picture because yesterday we have a special family photo, no? Today, a group picture here. Please move here, everyone. At the hand, we have a health. At the hand, we will have a health tea, health hand tea. Tomorrow we will restart at the same time, like today. 8:30 tomorrow. Please, the photographer. But ED said to say exact. Oh, okay. I can't change. Yeah. But you wait, I will move. Are you ready? Not yet. Yeah.